network, and the sum is, and we also need to sum over the different time period and geographical areas, especially with different traffic distributions. And for each site in the network, we will have some component of power consumptions. In reality, you will have air conditioner energy consumption, which cannot be ignored. And then the most interesting part is the RBS energy efficiency, the base station energy consumption. Well, and inside this, actually, they will have different parts. However, the most important part, or the most interesting part, is the carrier energy consumption that we can do research in. Well, so this is the logic we are using in our great project, and we are also using this logic together with many experts from different companies and organizations to do the architecture work in the GreenTouch. So we are currently leading this, coordinating this part together with many partners, and surprisingly, we have the same linear approximation functions, and we think it is quite good currently for approximation. And here, just a glance of what the carrier energy consumption is. It will have the dynamic power, which is something we tried very hard to minimize using large-scale MIMO, using high bandwidth or something like this. We just reducing this part. However, there are static parts, and the transceiver and consumptions for the circuit power, ADDA, signal processing in RF circuits. So this part have attracted not so much attention. However, it is very important, and we also find this part very important during these days of GreenTouch discussions. So if anyone sitting in this room who has expertise in the modeling of this part, or have expertise in the doing the design of this part, you can just let me know, or let any of the co-chairs or chairs know. And then also we have the static power consumption, which currently cannot be minimized according to the traffic. Okay, this is an overview of where we need to do work from the energy consumption view. Well, finally, we are arriving at the final part, which is the fundamental trade-offs on the green design. You may have seen this figure many times because this is the foundation of the fundamental part, and the four trade-offs actually connects all the network performance or metrics together, and we are actually trying to trade off some unnecessary redundancy in the system metric or requirement for some low power consumption. And we got one paper accepted by the IEEE Communications magazine, and I have uploaded this paper to the archive. So if anybody who is interested in the trade-offs and is willing to join the GTT project, you can have a look at that, and we can have more discussions. Well, in short, we call them DEE trade-off, BWPW trade-off, SEE trade-off, and the DLPW trade-off. Okay, here are some insights we obtained from Channel, and this is only, as you all know, for point-to-point Gaussian channel. But however, from this page, we can see that the fundamental for the channel formula, we can derive the monotonically decreasing the trade-off curves, and we can identify different regions. And some regions we have high power, and some regions we have low power. And currently, most of the systems are operating in the high power region, and for the GTT project in GreenTouch, we propose that for different trade-off curves, we may do different things. For example, for the SEE trade-off, I may note that you may note that in the GTT project we combined the SEE trade-off with the BW-PW trade-off in one trade-off. So here, in order to improve the energy efficiency, if we get the behavioral curve of the SEE trade-off, we have different ways. First, we can expand in the bandwidth at a given rate so that we are actually doing the trading bandwidth for power. And we can also reduce the transmission rate, like lowering the modulation levels so that we are actually trading the rate for power. And these two approaches are actually this arrow. We are changing the operating regions around the trade-off curve. And also, we can also do in this direction, we can develop novel radio transmission technologies or architectures that can improve both efficiencies simultaneously. That is, we can push the whole curve outward. So similarly, we have similarly, we have the same identification of the regions in power delay trade-off, and here we can similarly we can prolong the service time or transmission time to save more energy, and actually it's a trading delay for power. And we can also developing good schemes that we can push the curve inwards so that we can improve the efficiency simultaneously. Okay? And now I will give you some examples of research results we have done during the first year of our project to show that, however, in practice, it is not just like Shannon's formula tells us. We are not having a monotonically decreasing trade-off curves. We may have a very weird curves, which is depending on the transmission environment. This is the path loss exponent. And we see from here that if we consider about the static power and the circuit power, then the trade-off curves deviates what we imagine. And also we can see from this figure that if we use the total bandwidth and the total power, it will not bring you the maximum energy efficiency. So there is some maximum, the optimal point. So from these two figures, we should say that in practice, we need to be careful with smaller cells. I'm not saying that they are not good, but we need to be careful with them. And it is very necessary if we have the network management strategies involved to reduce some cost. And also, it is a very we need to take care when we are enlarging the bandwidth or resources we are using, because they may have some other cost in other parts of the energy. And here is another two examples. This one we show that the x-axis is the modulation level, and the y-axis is actually the energy efficiency. We can see that yes. Again, we can see the SEE curve is not monotonically decreasing. And we can see if we continuous transmission, the energy efficiency is not so high. But if we combine it with sleep mode, we can have better energy efficiencies. And sometimes if we use the conventional RF architectures, then increasing the number of antennas may not always help to increase the energy efficiency. So that's why we need also to have new architectures designed for the circuit part. And then, this figure shows that if we consider some relays in the systems, and it's important. And if the circuit power and other static power of the relay and the base station are both considered, we will also not have a monotonically decreasing curve. And it's very important to have the optimal resource allocation among the relay and the base stations. Okay? Well, here are some references. You can find them from the website, not website, from IEEE Explore. We got some initial results, but it's quite initial yet. Well, this is the first conclusion page. It shows that the value of our fundamental trade-offs. It serves as design guidance, and with design guidance, we know how far the goal is, and we know where we are in the matrix of this, and then we are trying to build the roadmaps from where we are to the goal. Okay. And this actually contains many design aspects. For example, the green physical layer design and the green resource management, the green network management, and the planning. So this is the value of the fundamental framework, and this is why we proposed these ideas and to the GreenTouch. And actually, we found many experts also have the similar ideas on the trade-offs, so we can work together to solve these problems for the future. Okay. So now, this is really the last page of conclusion. Now, this is some vision. And currently, we have exponentially increasing data, and because the efficiencies of the base stations cannot catch up with the data in growth, so the cost is increasing. How the gap between the cost and the revenue is so large. And can we really make it happen to reduce the cost so that we can have a reasonable revenue and a good profit for our customers? Let's make it happen. Let's make it happen via the device level design, site level design, and the network level design, or even the cross-layer design. Okay? So green radio or green research is an enabler of this change. And that's why we are sitting here together, so doing the co-research together in GreenTouch. Okay, thank you very much for listening to my talk.
Thanks, Chen. Do we have any questions?
Yes, I do. For your small cell models, were they essentially your macro scale base stations scaled down to small cells, or did you separate functions so that it was more like a remote radio head type of
Okay, for that curve you see, it's the very preliminary research that we just shrinking down the cell size. However, the cost model and the power model and the propagation model for small cells and the large cells are actually different in that modeling. Okay, but it's not heterogeneous. We are doing that part.
Have any other questions? Okay, at this point in time, we're going to close our open forum session. I'd like to thank all of our excellent speakers at the open forum.